Welcome back to school. Today we are going to start multiplying and dividing monomials.
To the video, copy this explanation on the right side of your notebook. Multiplying monomials. As a monomial is a product of numbers and letters, the product of two monomials is another monomial. Examples: 3a times 2a, multiply the coefficients 3 times 2 and multiply the literal part 8 times a equals, the final result is 6a squared. 5x times negative 3x squared equals, multiply the coefficients, multiply the literal parts. So the result is 5 times negative 3 times x squared equals negative 15x cubed. 3a times 5/6 ab equals 3 times 5/6 times a times b equals 15/6 a squared b. And don't forget to simplify before it's time to say goodbye. The final result is 5/2 a squared b. To multiply the literal parts, we apply the rule of the product of exponent. To multiply numbers with exponents have the same base, you add the exponents and keep the same base. Copy this scheme on the left side or do your own to remember how to add, subtract, multiply, and divide monomials. So, to add or subtract monomials, you need like monomials. To multiply or divide monomials, you can multiply or divide like or unlike monomials. To the video, copy this explanation on the right side of your notebook. Dividing monomials. The coefficient to monomials can be a number, another monomial, or a fraction. Examples: if you divide 6a squared b divided 3a squared b, when you simplify, the literal part disappears and the result is a number. 2. 15x to the power of 4 divided 3x to the power of 3, when you simplify, is 5x. 2ab divided 6b squared, when you simplify, the result is an a over 3b, a fraction. It's not a monomial. It's an algebraic expression, but not monomial, because the letter is in the denominator. To divide the literal parts, apply the rule for the division of exponent. When you divide numbers with exponent have the same base, subtract the exponent and keep the same base. Stop the video, copy this activity in your notebook, do it, and when you finish, play the video and check your answer. A. 3x times 5xy equals 3 times 5, 15, x times x squared times y. B. Negative 2ab times 4b equals negative 2 times 4 is negative a, and b times b squared. C. 4x cubed y times xy equals 4 times x cubed times x to the power of 4, y times y squared. D. Negative 2 over 3ab times negative 3 over 2ab equals 6a squared b squared over 6, and don't forget to simplify before it's time to say goodbye. A squared b squared. Stop the video, copy this activity in your notebook, do it, and when you finish, Play the video and check your answer. A. 10x divided 2x equals 10 divided by 2 is 5, x divided by x 1, so the final result is 5. B. 5a squared divided by 15a squared equals 5 divided by 15, 1/3, and a squared divided by s squared, 1. Final result, 1/3. C. 14a squared divided by negative 7a equals 14 divided by negative 7 is negative 2, a squared divided by a is a. Remember, exponents with the same base, subtract the exponent and keep the same base. D. 6x cubed divided 9x squared equals 6 divided by 9. When you simplify, 6 over 9 is 2/3, and x cubed divided by x squared, keep the same base and subtract the exponent. The final result is 2/3 x. E. 10x squared divided by 5x cubed, 10 divided by 5 is 2, and x squared divided by x cubed is 1 over x. If you simplify, x squared disappears and keep 1x, and if you apply the exponent rule, x squared divided by x cubed is equal x to the power of negative 1 is 1 over x. F. Negative 5a divided by negative 5a cubed equals negative 5 divided by negative 5 is 1, and a divided by a cubed is 1 over a squared, because when you simplify, 1a disappears, and the final result is 1 over a squared. G. Negative 16a to the power of 4 divided a to the power of 6 equals negative 16 divided by a is negative 2, and a squared divided by a to the power of 6 is 1 over a squared. So the final result is negative 2 over a squared. 8. 27x cubed divided by negative 9x equals 27 divided by 9 is negative 3, and x cubed divided by x is x squared. Remember, when you divide exponents that have the same base, subtract the exponent and keep the same base. Any questions?